You may see this year we have in the conference a lot of ISO C++ committee members. So Juan has been a committee member for a number of years.
The first one I attended was Madrid, but I was just showing up to see you guys. So I wasn't really a member. I was a groupie.
And he has a huge experience in the finance sector for a very long time, and he has worked with large code bases. And this is something that we last year we were talking over the coffee break about the problem of building large code bases and infrastructure that you need. And at some point we said, you should put this in a talk. And he really followed the guideline. So here he is. So Juan, thank you very much for being here.
Thank you. And thank you for inviting me here. I've been coming to this conference for a couple of years, and I always find it really exciting. So again, it's great to be back. As Daniel just mentioned, my name is Juan Alday, and I've been working in finance for a very long time. And this talk is called The IT Pitfalls of Rapid Growth, which is a very generic title, right? It can mean a number of things. I mean, at the end of the day, it's all about one word: growth. And growth is a really big word. In my dictionary, it also means another word: money. Every single one of the changes that you make in your companies cost a lot of money. And the bigger the company, the larger the cost. Again, when I say growth, it applies to both the companies as well as departments, business areas, you name it. Remember that in some cases, there are very large companies with departments that are bigger than most middle-sized companies. I've worked for some investment banks that had over 1,000 employees working in fixed income, over 2,000 working in equities. And in some cases, they were doing systems that were completely orthogonal. There was no communication. There were like two different companies. As I said before, that is money, and it involves a tremendous cost in keeping those systems together. So I'm going to be talking about three things here. The first one is the importance of early IT infrastructure planning. I'm going to be talking about some pitfalls that you're going to encounter once you move from mid-size to large, and the consequences of inadequate IT planning. And just so that we're clear, before when I mentioned growth, just some statistics. 55% of all US employees work for large corporations. In IT, about 25% work for large corporations and 27% work for very large medium corporations. And that doesn't even take into account all the special workers with special visas and things like that, which account for about 100,000 employees every year. So chances are at some point in your life, you're going to be working for one of these companies. It's really comfortable to work for a startup. It's great, but the startups grow and you will grow too. And at some point, again, there's a big chance that you're going to work for these companies if you don't do that already. Show of hands, how many of you work for large corporations, say over 300 employees? Well, that's what I meant. Anyways, what I mean by infrastructure planning fundamentally is two words. You can just read the rest, but I just want you to focus on two things: knowledge and foresight. You need to have some understanding as an individual contributor or as a manager of how your company is going to evolve and how is it going to scale. And that knowledge is what's going to enable you to address future problems and eventually pass that message along either upstream or downstream. I always quote Uncle Bob. I just love him. He's great. And he has this sentence, right? Later equals never, which is also called the Blank's Law. Dave LeBlanc is attributed with creating this phrase. In any case, it's great. Uncle Bob also has another sentence, which is awesome. The only way to go fast is to go well, which is very applicable. Let me talk about examples of companies that did not everything, but did a few things right, left and right. I'm just going to give you two examples here, and those examples saved them a lot of money. The first one is these fellas, Google. And you don't need to like everything they do. I'm not willing to the thou shalt not throw exceptions. But the truth is that they created, for example, the term SRE, which is great. They focus very early on infrastructure planning, on what are we going to do with our servers, what are we going to do in terms of like farming, even programming languages. We are going to have like a homogeneous environment. The second one is this, fellas. These guys, LinkedIn created Kafka, and Kafka is used by a lot of people. And originally it was just created as a messaging bus, and it evolved into a distributed streaming platform, which is used by thousands of companies out there, if not tens of thousands. I've used Kafka a lot, and I find it pretty awesome. The concept of the distributed commit log, things like that. This is used in a lot of things. There's even this guy out there trying to sell a fix engine that uses Kafka as an underlying mechanism for distribution of sessions, for those of you who knows fix. It's a protocol in the financial community. Now I'm going to talk about Pitfall. And again, I'm just giving you a lot of the definitions, but I'm not going to read them here. What matters really is the last thing. The larger the system gets, the bigger the pitfall becomes. At the end of the day, it's just about things that are going to pretty much ruin your infrastructure, your software development, how your company will evolve in the future unless you pay attention to it. And you can overcome them. But as I said before, it becomes really expensive in terms of like people, in terms of infrastructure, in terms of money. A lot of you might probably be thinking, well, he's just talking about technical debt. And technical debt is real, but this is not about technical debt. And we all know what technical debt is, to some extent. And of course, I wouldn't be talking about that without the obvious meme that everybody loves. And some might think, well, yeah, whatever, this is not what I wanted to see. There's no XKCD meme for technical debt, unfortunately. So I was going to name it something else. And I thought, well, this is probably growth negligence or foresight negligence or something like that. When I started talking about this talk a year ago, that's what I was going to call it. And that's what was originally my slides. And then, as it usually happens, Kevin Henley came, and he happened. So Kevin Henley came up with technical neglect, which is an awesome description of what I want to talk about. And this is my little definition of it, which is, again, is the root cause of many issues attributed to technical debt, but it's not. And it does cover software, IT infrastructure, and hardware. It's a little bit of everything. And Kevin is awesome talking about this, so I'm just not even going to pretend. I strongly recommend you go and watch his talk. He's been doing the rounds with this talk for about 6 to 8 months. He started like PyCon, he's done like NDC, and it's a really, really awesome talk. There's a link at the end of my slides. And anyways, let me just go through this. I have 8 pitfalls that I want to address here, even though the list is much, much larger, but well, this was a 2-hour talk condensed into 35, 40 minutes. So the first one is build systems, source control, stage deployment, programming languages, common tooling, operating systems, the use of cloud, and what happens to people. How do people interact in your company? I'll address that later on. The most important thing is that all these items and many more have 3 things in common, at least. Scalability, consistency, and cost. For every single one of these elements, you need to think about how you're going to scale them up. You need to think about how consistent they are with the rest of the infrastructure and with the rest of the organization, and how much can you afford not to have them today. So let me go through the first one, build systems. As I just mentioned, one very, very important feature that you need to look after when you address the need for a build system is consistency. And by consistency, I mean whatever comes out of it, it has to be consistent across different areas and different stages. And by stages, I mean deployment. I mean, hey, I want this build system to produce an output that is going to be used later on in my static analysis engine. Or I just want to make sure that I build my software At the same time, for my 7 or 8 different platforms, because not everything is Linux here. You have AIX, you have Solaris, you have embedded systems. It's very complicated, and that touches into the next point, which is scalability. Otherwise, dependency management just becomes a mess. And most importantly, without dependency management and scalability, you turn your company into a silo. And that's what I mentioned before. The equity department at this company that I worked for had a build system and a continuous testing system built on Lua, of all things. Fixed income had a build system and unit test framework built on Python. At the same time, that is ridiculous. Anyways, you also need to be able to provide proper integration and delivery because everybody right now is very hot with like CI/CD. Reproducible builds are very important, and I've talked to a lot of people about this. How are you going to reproduce your builds 5 months from now when there's a client asking for a bug fix for something that got delivered to that person 5 months ago or 5 years ago? QA, you also need to have, and I'll talk about this later on, you need to have a proper QA mechanism or department in some cases that will evaluate how your software works. And of course, I just said that integration builds are really important for a number of reasons. And I understand there's a lot of controversy between typed and untyped systems. There's a lot of Python folks saying, well, we don't really need an integration build at the end of the day. I think that's nonsense. Integration builds are really important in the context of typed languages and in other languages as well. There can only be one. Especially the older people here will know what this is. It's Highlander. So resist the urge to have multiple build systems. There can be only one. Otherwise, you can get away with 3, with 4, with 5, but it's a matter of what? Money. Source control. I've been through the wars of source control systems. I've been through the clear cases, the SVNs, Perforce, Git, and they all work to some extent very well. It really depends on the scale and the structure of the organization. I've seen companies that had a source control system based on creating a tarball at the end of the day on their NFS directory and saving that as code for today, and this is how they unrolled. When you start getting into the millions of lines of code, that's a problem, but it's addressable. When you start getting into the tens of millions, you have a problem. This company actually is in the tens of millions, so problem. Maturity of the tooling and the infrastructure, and this is also key. You need to have tooling that interacts very well, not well, very well with this source code control. Security and access controls. Security is very important right now. In fact, it's becoming a legal requirement, not only for external attacks, but also for internal developers that don't know any better. A lot of people here have experience, maybe not if you're lucky, people that have committed really silly things, or in some cases removed the whole tree from source control. Sometimes, sure, you can roll back and you can unwind it, but generally speaking, you need to disallow people from doing that. The source control system that you choose is also going to affect your branching and your merge strategy. And I'm not talking about renaming master to main. I'm talking about how are you going to branch your software so that you can have hourly, daily, weekly, monthly releases or ad hoc. That maintenance becomes a problem, and we can talk about policy too, but that's another story for another day. Support and reliability, which is very crucial for large and middle-sized corporations. What happens if your source system goes down? Who do you call? Do you have an action plan for that? When you have a small company, you always call the fella in charge of the Git server, and you tell, hey, there's a problem with this. Sure, I'll just reboot the server. What happens when that source control system is used by 10,000 users at the same time? Who do you call? So you need to make sure that whatever you have has a proper SLA. And I understand that the whole SLA concept is a bit misguided because there's a lot of managers that just want an SLA so that they can get away with not doing anything. I'm not talking about that. Monor Repos are hard because that's going to be something that is in the back of your mind right now. There's all this controversy between Polyrepo and Monor Repo. And The truth is that they are very hard, and they're very hot right now. There's a lot of people talking about Monor Repos, and a lot of people are moving from poly to mono, in some cases without thinking about what they're doing. Don't get me wrong, they're really awesome. But it requires a certain maturity on your development cycle that some smaller to medium corporations do not have. It's really great when you have 10 people working with Macs and hacking in a small office to just switch from one to another. But at some point, moving to a Monor Repo, it's very costly. You need to have a strict set of guidelines as to not only where you put your code, what kind of code can go inside, how it interacts with other areas of the repo or of the company. Migrations are really difficult. If you have a poly repo system with, say, 100,000 repos, 50,000 libraries, how do you move them into a Monor Repo in a staged and uniform way? Those are very big problems. I was going to say those are very big concepts that are much more addressable if you start early on. File systems, and this is a hard one, file systems and platforms affect performance, and size does matter. A lot of people use Monor Repos in the context of Linux. Linux is great, and if the size is not too great, well, you can just have a fuse layer and you're done with it. But what if you're not doing, even in Linux, what if you're not doing Red Hat 7.6, for example, and you cannot have like user namespaces? You cannot have it unless you give root to some system. What happens if you have AIX? What happens if you have Solaris? What happens if you have some really old system that doesn't support all these new features? At this point, you need to go through a bridge and your file system becomes unbearable. And in some cases, even worse than NFS. Just like before with the source control, you need to have a specific policy as to how you're going to branch your code to go into production. And this is a favorite one of mine. Beware of confusing Monor repos with monoliths. Incidentally, I normally do not call Monor repos. I call them mega repos, which is a concept created by Jonathan Creamer, who also created the concept of DevOps instead of DevOps. And come talk to me after the call, after the talk, and we can talk about this. If you have a Monor repo of a certain size, you're going to have a code governance team dedicated to managing the code, creating those set of policies that I mentioned before, and organizing how the code inside works. So the sooner the better. Otherwise, and you've heard some horror stories out there about Monor repos, it just becomes impossible to govern. There are great success stories about migrating to Monor repos. For example, Microsoft a couple of years ago migrated from their poly repo system to a Monor repo, or at least as far as I can tell, 3 Monor repos. But it's just working fine. But again, it's Microsoft. And they invested a ton of money, a ton of time, and a ton of people into it. Maybe your company is not mature enough to do that. So the sooner the better. And obviously, once you start talking about Monor repos, you need to have something in mind. Deletion strategies. Because at some point, your code is going to become abandonware. Peter before mentioned something about code that hasn't been touched in 20 years. That's not uncommon. I have stories that would just make you cry about this. More to that in a second. There's an example of that. Anyways, let me talk about separate dev, QA, and prod environments. And I'm just going to fly a little bit through this. It's very important in the context of a middle or a large corporation to have a fully isolated dev and prod environment. And if you can afford it, have a QA environment. The worst thing you can do is go back to the old paradigms where the developer just cranks up something, builds it, goes to the production box, copies the software, kills the executable, runs it again, and off you go. We're running in production. This is awesome. You can no longer do that. When you have thousands of employees, you need to have a proper separation and you have a proper staging environment. And I understand that they always prioritize rapid development cycles, but those also consume cycles. And again, it's a matter of cost. It's a matter of the complexity of your company, and it's a matter of how many resources you have. But you need to really start thinking about how you're going to split your environments. Because the worst thing you can do, again, is to ship something to prod that you just wanted in dev. Who knows this company? A few hands here. This is Knight Capital, or was. Knight Capital was the absolute leader in the US equity market, electronic trading, back until 2012, up until August 1st, 2012. So long story short, the New York Stock Exchange announced a new program for trading called RLP. And Knight Capital decided back in 2011, almost a year before, that this thing was never going to happen. Why invest in this? We don't need to. This is never going to go into production. Anyways, June 2012, New York Stock Exchange decides that RLP is going to be something, and that something will start trading in August 1st. So these fellows pretty much had a month and change to create a new execution model. And what did they do? They decided that they were going to reuse some parts of their executable that were no longer used and put the new code there. And they used some code that hadn't been used for 10 years, since 2003. And they worked for a month and, they thought they were ready and they put that in production. And well, a lot of things went wrong. First of all, the person in charge of compiling this application copied the new executable to 7 out of the 8 production servers. I mentioned that they used an old bucket of code to put their code, right? They never changed the flag that enabled the new feature. So in 7 out of the 8 servers, it just worked fine. The 8th server thought it was still running the code from 2003. And it started doing what it was supposed to do, which is buy high, sell low, because it was a test service. So a lot of things went wrong, as I said before. This thing started buying like crazy, selling like crazy. 45 minutes later, they have sent 475 million orders into the market, over 190 equities. They were at that time at $1.7 billion in losses. Meanwhile, the New York Stock Exchange was trying to call frantically the CEO of the company. The guy had a knee surgery the week before, and he was at home. He wasn't picking up the phone because, well, he was recovering. They didn't know who to call. After 30 minutes, they finally reached the CIO, who, what did he do? He started calling people instead of just pulling everything off the market. Long story short, 2 hours after the market opened, they finally took Knight off the market, and the company was dead. A year later, it was acquired by Getco, and pretty much all the employees were fired. That was the end of the leader in equity trading, just because of one mistake, according to what they said. In my opinion, it was a combination of a lot of things. It was a combination of code and configuration management issues. They never had any source control policies. They never had any code deletion policies. They never had any code validation policies. They had no unit tests, and Phil Nash yesterday was talking about this a lot. And Pete, you also talk about guts in the context of what Kevin says. There was no testing procedures whatsoever. They didn't have a single unit test. There was no deployment strategy. Normally, software needs to go through stages, and you validate that it does the right thing. No, this guy just basically copied an executable to 7 machines. And there was no incident response planned. When they tried to call the CEO and then the CIO freaked out. He didn't know what to do. In my first job years and years and years ago, I'm old, I remember I was in the FX desk at a major investment bank, and the head of the desk had this really big red button. You've seen that in a few memes. He actually had it, and that was take me off the market. And you push that, and immediately you would take all your orders out of every single market. I'm not saying you need to have a red button, but you need to have a way to tackle these incidents. That is, you need to have an incident response plan. Choice of programming languages, this is going to be a good one, because in small companies, you can do pretty much whatever you want. And you go to a new company and you decide that you like C++, and that's great. Now, I'm not going to talk about C++. Actually, that's a really good choice for a lot of things. But these are the 5 things that you need to ask yourself. How many languages can I support in my organization effectively? What's the longevity of this language? And by that, I mean, I don't really mean has it been around for a long time. What I mean is, do I think that this language will be around in 5, 10 years? And that's something that Jose Daniel addressed last year in your opening statement, for example, when you were talking about C++ versus Rust versus, well, there's a lot of options. But is it going to be here? Carbon? I don't know. Scalability, which is another really hot topic, and there's been a lot of interest in this, and people have spoken a lot of this in the context of C++. I know that C++ scales very well into the millions of users. Can I be sure that Rust does it? I don't know. And I like Rust, don't get me wrong, I do some things in Rust. But I do not know yet about the scalability factor of that or other languages. Talent retention, that's very important because we're all hackers. We all like to program a lot. But when we're working for a small or medium company, that is great. What happens in 10 years? Where's the talent going to go? A lot of that talent might actually go to another company where they do the latest and greatest. Are you going to be able to hire talent that knows that language? And another important point is the economics of a language. Who pays for it? I know that C++ is paid by a lot of vendors and it's an ISO standard. I know that Google has a heavy interest. I know that Microsoft has it. I do not know about all of these languages. They are niche in some cases. What if the developer gets hit by a bus? And that has happened in the past. You know what this language is? Delphi. This is a language that was very heavily used in the financial community in the 2000s. It was a successor of Pascal. There's still code out there that uses. This is still in production. That's a problem. This hasn't existed in 20 years. Ruby. Ruby was awesome. I'm talking about Ruby, not Ruby on Rails, by the way. Although there's some, I'm not going to go there. But Ruby was created 30 years ago, and I've done Ruby, and Ruby is great. But suddenly, at the time when Ruby on Rails came up, everybody was interested in Ruby. And suddenly, I started seeing Ruby all over the place. And it didn't really make a lot of sense, but it was cool, so people used it. Why? It doesn't make any sense to me personally. And again, I play with Ruby 3, version 3 is great, but nah. Go. This is going to be a bit controversial because 5 years ago or 6 years ago, we had the explosion of microservices and everybody was doing Go. And Go is great for what it's good for. But suddenly I started seeing in the financial sector a lot of applications in production using Go. Why? Simply because they brought a couple of people that were interested in this language. Go is not really as hot today. What are we going to do with this one? I'm going to give you one that is my personal favorite. OCaml. And I love OCaml. At a previous organization I used to work for, I actually introduced or co-introduced OCaml to the organization with my boss, Shane Fletcher. Great guy, architect extraordinaire. And it was awesome. And I'm going to quote Pete when he said, C was a language created by computer geniuses for the best part, or computer experts, used by computer experts, but then it trickled out. And that's a problem. The same thing happened to us. Suddenly in this company I used to work for, people started using OCaml and it was just a snowball. So anyways, what really freaked me out is around 2014, I attended ICFP, the International Conference for Functional Programming, in Stockholm. And there was a very interesting talk, OCaml in the International Space Station. And I was like, what? At that time, I was really finicking and playing with the OCaml compiler because I had to migrate it to Windows. And I knew a couple of skeletons in the closet of the compiler. I stopped looking at that, so I don't know if they got fixed or not. But I was really worried, like, well, this thing is going to fall. It turns out it was just one of those hype things, and this was just used as in some QA processing batch server in a ground station. It wasn't affecting the International Space Station, but I promise you, I freaked out for a second. And I love OCaml. Lua. Lua was great, but as I mentioned before, someone decided to build a whole build system based on Lua. Very recently, a colleague of mine came to me because she knew I know Lua, and she was like, wait a second, can you help me here? I have this repo that doesn't build anymore in our integration build. So sure. It turns out this thing was using Lua files from 7 years ago. Nobody had touched them. They were no longer building. So, that's typically what you're going to find. And my personal favorite, Java. Java has been used wrongly for so many years in the financial sector as a C with a virtual machine, where people just basically code C structures, pre-allocate, and if the application dies, you just start again. Major investment bank, equity routing server written on this. This is how it's still running. There's another couple of firms. One of them is in Chicago. There's one of those Flash boys that work in like high frequency. They run on Java like that. That's very scary. I was mentioning the economics of programming languages, and I strongly recommend you actually watch this talk by Evan Saplicki, where he explains in a lot of detail how programming languages are getting paid for and how they're getting developed and who foots the bill. Let me just fly a little bit. Unrestricted use of common tooling, which is also something that you guys have all seen before. Including me, like 15 years ago, hey, there's this thing called Simic. It's really great. I'm just going to put it in production. There you go. And you put it in production. And that is great. But you need to have three things in mind. What are the maintenance strategies for this tooling? And I'm not just talking about Simic. I'm talking in general. Who is going to take care of that? Hannah mentioned yesterday libcurl. Who's maintaining libcurl in my organization? Who's looking for bugs? Who's looking for patches? Someone has to do it. Is it scalable? Can I ensure that this product is going to scale in the thousands of users concurrently in some cases? And will you dedicate resources in the future to this thing? Will you, for example, change Simic list.txt with a team of people whenever Simic decides to deprecate something or make something illegal? And since I just mentioned Simic, I'm going to give you one example. Simic minimum required. That's the first thing you need to add to any Simic list.txt. And you need to specify the version. Anyways, everybody right now uses Simic over 3.4. Pretty much everything before is considered non-kosher. It's deprecated. And at some point, that will be an error. If you look for Simic minimum required version 2.6, you get 30,000 hits on GitHub. But if you look for 2.8, you get 75,000. Those are 75,000 files that at some point will not work unless you do something with them. 3.1 is 21,000, but then it's more things. You remember when they made the switch from include directories to target include directories? 690,000 hits on GitHub alone. Link libraries, and you can go on and on and on. On top of the deprecation, you gotta understand that they're also going to start evolving things. So things that you have added yourself are things that Simic, fortunately, will use in the future with internal stuff that they have, like interface libraries, package config dependencies, dependency management. This is really hot, C++ module generation. The Bloomberg folks were talking about this yesterday, and it's public knowledge that Kidwerg is engaged by Bloomberg to enhance the module management. SBOM generation. We've all heard about SBOMs too. And the Conan folks yesterday made a wonderful presentation where they mentioned that. And well, fortunately, Conan 2 addresses some of these features because you're no longer going to have to modify your Simic lists. You're going to be using Bootstrapper files. You're going to be using toolchain files. There's a way to go over this, but that only for Simic. There's a lot of tooling out there that will never give you that option, mostly because it's not a commercial tool on top of it. Operating systems. Again, I'm going to fly through this. Just how many can you afford? What's your upgrade strategy? How are you going to move from, again, Red Hat 7 that goes in the light to Red Hat 8? What's the security? Who's taking care of the CVEs? Can you patch them in time? I've heard this thing before. We can migrate to C++ 20. Our OS comes with an old compiler. There's a major electronic equity market in the US that is still running with GCC 4. That is very sad. Red Hat 7 goes end of life in June. We must get a plan soon. Each department can take care of their machines. Oh, that's not my problem. All my servers are patched and they're running Red Hat at least 8. Great. Awesome. You know what? This is my favorite. All our libraries will work after the upgrade. Yes, because sure, if you see any of those things, stop, go back and think again. Again, I'm not just trying to be funny. These are things that happen to medium and large companies, and that's a real problem. Cloud computing. I'm not going to start talking about cloud computing. I am very opinionated. I'm not going to get there. Just as a refresher, those are the 4 types of deployments. You have the private, public, hybrid, and then there's multi-cloud. And the 4 types, or 3 plus 1, because, well, function is a bit of an iffy thing. In any case, cloud computing is great when you're a small company because you don't need anything. I'm just going to discard IaaS, and I'm just going to focus on PaaS and SaaS, basically, because that's what most people use. And platform is really great. You need to build a company. Hey, you engage with Azure or something, and it just works. But as you grow, you need to start footing the bill. I don't know if you know what a timeshare is, but to me, cloud computing sometimes, especially just public cloud computing, looks like a timeshare. A timeshare is a concept in the US where you buy shares of an apartment on the beach, and you have 2 weeks per year to use it. And the first year, you always get it in August. But from that moment on, you always get it in March. That's terrible. So the first thing that comes to your mind when you hear the word timeshare is run. Again, I can talk about the disadvantage of cloud computing in the context of just a public cloud, and I'm a firm believer in a hybrid approach where you keep all the eggs in your basket, but if you need an expansion in capacity, you go to a public cloud, but be very careful. There's a really great talk. I like sending you to other people. That way I don't need to do their dirty work. There's this really great talk with David Hiner, the creator, incidentally, of Ruby on Rails, where he talks about how he moved away from the cloud, and he explains how the economics of cloud computing at a certain level just do not make sense. You might, and we agree to disagree here. I'm totally on his side. Anyways, I'm going to talk about my last point, which is workforce. And have you seen Gartner hype charts before? They're great. Everybody uses them for everything, including myself. So this is a chart about the enthusiasm of workers. Because when you work for a small firm and you know everyone, we're all hackers. We all like to program a lot. We spend many, many hours in front of a keyboard, and we just love it. And that's how a company starts. And then you get to your peak of performance. And a lot of these people just leave, and you need to start replacing them. And once you get to a certain level of complexity and of size, you must realize something that is very, very important. Not everyone is as excited as you are. People sometimes, they just want a job. They do not program on the weekends. They do not stay in the office at night. They do not remote in. They do not hack in other languages once they get home. They have their family or their friends, or they just want to fly a plane. And that's totally fine. That's a major mistake with one of these companies. Suddenly they grow in size and the productivity suddenly drops because people are not working 14-hour days anymore. And that's okay. You just need to account for it. Last but not least, I'm just going to give you another example of what goes wrong when all of these things together combined simply are not followed, which is this little company. I'm guessing a lot of you do not even know who these guys are because they no longer exist. Friendster was the old Facebook. That was Facebook before Facebook existed. And it was very hot. Everybody wanted to be on Friendster. The problem is that they received money from VCs and they grew. And instead of investing in IT and these policies, they invested in a vice president of marketing, a vice president of something else, a sales whatever, public relationships, human resources. Suddenly, they started having performance issues. I remember when trying to load Friendster would take 40 seconds. It didn't last long for people to realize this is just not gonna work. And it's just a classic example of how technology misuse can just basically make you go bust. At the end of the day, Friendster, who was going to be one of the first multi-billion companies, sold their assets or their patents for $30 million to Facebook, and that was it. What can I do other than complain and go away? As I said before, it's growth or die for these companies, right? They're interested in growing and they can listen to what you have to say. What's important is that you understand that if you are at the top or the bottom, there's a lot for you to do. If you are an individual developer, trickle up, talk to your team lead. That will scale up. You can also organize yourselves. And there's this concept that is working now very well in the small firms. And also it's actually a standard in cybersecurity, for example, which is the champion program. And champion programs work phenomenally well to gather leaders in each area and then get together, find out what you really want to change, and then move that up. There's a really good talk by Matthew Revel on the 4 archetypes of developer champion programs. I strongly recommend you watch that again because it's going to explain a lot about what I'm talking about. The second thing you can do is, and believe it or not, this works, community consensus. Talk across all your peers about what works, what doesn't, reach out to other stakeholders, and get feedback. There's another talk, and that's the last one I'm going to put out there by this old colleague of mine, Sherry Sontag, on building consensus on a set of rules for their massive C++ code base. This is a talk that is doing the rounds right now. Sherry spoke at CPPCon, and last week she was at ACCU. And one of the lessons here is that not only do you build consensus by talking to other people, but then those people come back to you with what works, what doesn't. And it's kind of like a back and forth thing where both you as a department, as an individual, or as a company evolve and get to a certain maturity level. I think it's a great talk and I strongly recommend you watch it. And I'm really running out of time. So I was gonna ask for questions or reach out to me later.
Thank you very much. So, questions?
Oops, careful.
Thank you for the talk. I found it really interesting. And also regarding to C++, that's why we are all together here. How difficult is to find, from your perspective, to find good talent in C++?
It is very hard, and it doesn't help that not a lot of colleges are doing what Carlos Tercero is doing here in Madrid, which is also teaching new talent C++. I think it's unfortunate that a lot of companies are shutting down their internal employee training in C++. So I do not really have a really great answer for you. I think those are the kind of things that fix themselves with time because of what I said before, the obsolescence of some other languages. They all suddenly die, and C++ is still there year after year. The fact that there's a lot of new features, well, you probably saw 3 years ago that C++ is becoming hot again. Users are starting to come back to our realms of computing, right? And I think that is the answer, to keep evolving the language while honestly having these talks. There's a lot of hacking, a lot of conferences on C++ that were not there 10 years before. 10 years ago, you had ACCU in Oxford at the time, and you had pretty much nothing interesting other than BoostCon in the US. Now, I do not even know how many conferences they are. I think that's one of the battlegrounds where we need to stake our claim into having a really awesome language.
Do you think that competition, for example, nowadays everyone talks about Rust, probably shadowing C++, but I think in the end, like you just said, C++ is becoming relevant again. Is it possible that new competitors make some established languages that are probably getting out of popularity? They probably try to get better with competition?
Yeah, I think that competition is something that is definitely making C++ better, for example. And I think that we are seeing now a lot of competition, both in the context of languages and in the context of tooling. We have Circle now. adding all these like esoteric features, or not so esoteric, things that are actually useful to the language. Will it work for large-scale development? I do not know, but it definitely is going to trigger a move in the rest of the compilers. Look at what Microsoft did years ago when they basically revamped their whole Visual Studio infrastructure and the preprocessor, and they were one of the first to have concepts. Visual Studio got better because they had competition. They used to be the evil empire when I was a kid, remember? Not anymore. They're doing a lot of things right, and that is awesome. Competition makes things better.
Thank you.
Also, I think, for example, if you look at GCC, it improved just because Clang was out there.
That is absolutely correct, and that's a great analogy.
Can you explain a bit the difference between technical debt and technical neglect?
Yes, although I recommend you watch Scandling call, but yeah, basically technical debt is something that can be addressed and you know that it's out there. The difference with technical neglect fundamentally is that technical neglect is something that you just ignore. That's it. Technical debt is something that you're going to address at some point. And sure, we don't have enough cycles, but we know that problem exists and we're planning on fixing that at some point. Or with technical neglect, we just say, oh, I don't care. And that happens a lot.
In your experience, jump to a Monor Repo is something that you could recommend for its kind of companies?
Can you repeat the first part?
The Monor Repo approach is something that it could be useful for any kinds of company or any kinds of department, or you need to have some elements for be something productive?
In my personal experience, more than my knowledge, I believe that Monor Repos are extremely useful if a company has either an early start or it has a certain set of guidelines that employees have been trained to follow. If you suddenly switch from a paradigm of a polyrepo where everybody just commits their code, whatever they want, whenever they want, and you try to move to a Monor Repo, again, it's not that you cannot do that, but it's going to cost you a lot in terms of like cycles, employees, because they might leave the company because they don't like this set of rules. And of course, as I said before, code governance teams and things like that. So, but in my opinion, if you have that set of like that maturity level, which is something that small companies already have, then sure, my Monor Repo can work. It really depends on your product too. If you're a library, I don't want to overextend myself, but if you're a library-based company where you just have thousands and thousands of libraries, and then you just have a couple of executables, moving to a Monor Repo is going to be very difficult. If you have specific applications that you're delivering to clients and you do source-to-source builds, then it's much easier. I didn't cover here source-to-source builds because I had to chip in some of the pitfalls, but source-to-source is another one.
Hi, thanks for the topic. I was curious about the topic, the example you gave about the Kafka and linking, right? So my question is, how do you stop, like, when you are trying to build something, how do you detect that you are reinventing the wheel or not explore the world enough? Or how do you encourage to actually go and build something about your own and actually have to own it?
Well, the Kafka case is kind of special because there was a lot of history behind it when it comes to messaging buses, right? And I guess people knew that something was missing. They were the first ones to build it, and they addressed a market niche that nobody had covered before. But you mentioned a very interesting topic here. I don't know if that's where you want me to go, which is reinventing the wheel, which is something that a lot of people do. And it's a combination of things. There's something that is very endemic to us, which is it's what I call the look how smart I am code. That is when, again, I'm an old timer. I remember the explosion of templates. Everything was a template, but before that, I remember the explosion of design patterns, when everything had to be a design pattern. Alexandrescu came up with this book, and suddenly everything was a policy. And policy-based design was all over C++. It takes years for things to become more pragmatic and for people to understand that this is nothing more than a guideline. It's not a requirement. So the same applies to this, right? I think that if you have a certain level of maturity, you understand that you do not need to write everything. And that's kind of like the paradigm of open source as well. But at the same time, if you identify a niche, go for it, but go for it fast. You need to really address that issue quick, because otherwise, well, you might as well just wait. And that's the worst thing we can do.
Okay. Last question.
I wanted to ask, in your opinion, how would you index knowledge easily in the company such that when people leave, which is inevitably, other people will find that knowledge? Because in our company, there are a lot of talks about documentation. We create a lot of documentation, and then people can't find it.
Yes. Documentation is a hard topic as well. I wouldn't even go there. I would just go first to something that is also endemic of large companies and middle-sized companies, which is for every 12 project, there's only 5 developers, because again, it's about cost. And the problem is that each developer is doing 5 things, but you never have 2 people working on the same project. That is the problem. Once you have 2 people working on the same area, that knowledge starts to trickle out. And again, the options are limited. You cannot just have everything doing the same thing. When it comes to documentation, that's where you need to have both a code governance doesn't just focus on establishing a set of guidelines for you to follow in order to place code in a repo. It also establishes some guidelines on how you need to document your code, and more importantly, in the context of big corporations, how those things interact together. Because for me, it doesn't make any sense to read your Doxygen-generated files. What makes sense for me is to know how your API interacts with mine or interfaces with mine. And that is the thing that a third-party team needs to focus on, because you as a single person, you can put some things into that and put some pressure, but it's not your job in the sense that you don't have time for that. That's what happens to large corporations.
So thank you very much.
Thank you.